Hey guys, I hope that your homecoming was fabulous. You guys have notes today on rational functions. This is day 1. Tomorrow we'll add a little bit to it, but hopefully you guys will be able to understand everything through here. So there are 4 types of factoring. It says 3, there are 4 though. So GCF, T-chart, difference of perfect squares. You have your formula right here. Remember, you're going to do a plus and then a minus with the square roots. Okay, and then remember for your perfect cubes, you have your formulas here as well. Okay, don't have to memorize them. Whenever you have tests and stuff, you'll always have that available. So we are going to talk today about points of discontinuity. These are values of x that cause the denominator, okay, which is the bottom, to equal 0. Now, the reason that these create points of discontinuity is because that basically creates a divide by 0 situation, and that is not allowed. So there are 2 types of continuities. The first one is a whole. So let's say you have a quadratic graph, and you just have a single point, and basically that one point gives you an error. Okay, that is a whole. Okay, the other type of discontinuity that you can have is a vertical asymptote. Okay, we have talked about those a little bit, but let's say that you have an asymptote at x equals 2. Basically what that means happens is that when you have, okay, your asymptote there, your graph is going to get really close to that line from both sides, but it's not actually allowed to touch that value. So that's what a vertical asymptote is. So the way that you can tell the difference is you are going to factor out the top and the bottom. Then any repeated factors are going to cancel. Those create holes in the graph. Any factors remaining in the denominator, which is the bottom, okay, create vertical asymptotes. Okay, then the simplified expression is basically just whatever is left over. Okay, so let's take a look at example 1. So first thing we need to do is factor the top and the bottom. Remember, 4 types of factoring. I got to factor this guy, I got to factor this guy. So 8x plus 32, hopefully you realize that has a GCF. I can divide both of those by 8. So I'm going to pull my 8 to the front here. Out of the 8x, just an x is left over. Then 32 divided by 8 leaves me with a 4 left over. So the top, check, we factored it. Okay, the bottom I'm going to have to T-chart. Okay, so if I set up my T-chart over here, okay, I have a 4. I need him to add to 5. Well, 1 times 4 are going to be my guys. So then I have x squared plus 1x plus 4x plus 4. Then I look for my GCF. I can divide both of these guys by x, both of these guys by a 4. X comes to the front, x plus 1. 4 comes to the front, x plus 1 again. Because 4 divided by 4 gives me a 1. Sorry. Okay, so from there, my x plus 1s are repeats. So I'm going to pull that to the front. And then what's left over is an x plus 4. So on the bottom, I have an x plus 1 and an x plus 4. Okay, let's go back to our steps. So step number 1, we factored, check. Step number 2, I'm going to cancel out repeated factors. So what that means is that I notice here that I have an x plus 4 on the top and an x plus 4 on the bottom. That means that there is going to be a hole in the graph at whatever makes that 0. Well, think about it. If I set x plus 4 equal to 0, bring the 4 across, it's going to be a negative 4. Now, probably you already knew that. We've been changing the sign on those for forever. Okay, vertical asymptote is whatever is remaining in the denominator, which is the bottom. So I see that I still have an x plus 1 left over in the bottom. That means I have a vertical asymptote at negative 1. Then from there, my simplified expression is just whatever didn't cancel out. So I had an 8 left over from the top. I have an x plus 1 left over from the bottom. So there'll be a hole at -4, an asymptote at -1, and my leftover expression is 8 over x plus 1. Okay, when you're ready, go ahead and turn the page. We will do a couple more examples off the back. Alright, next one. I notice at the top, I'm going to have to think about it, what kind of factoring you would need. Okay, x squared plus 4x minus 12, that is going to be an example of t-chart. So I'm going to have a -12 at the top of the chart. So I can do 1 times 12, 2 times 6, or 3 times 4. But I need my numbers to subtract to 4, which means I want 2 and 6. Minus on the 2. Because remember, if I minus the 6, I'd get a -4, and that's not what I want. So I have x squared minus 2x plus 6x, and then minus 12. Okay, well, those both have an x. Those both have a 6. So x minus 2 is one factor. 6 comes to the front. X minus 2 is my second factor. Then I notice that these guys match each other. That's what I want. So I have an x minus 2 and an x plus 6. So I'm going to rewrite my expression over here as a minus 2 in one parentheses and an x plus 6 in the other. Now take a look at the bottom. I have a 2x plus 12. I notice that I can GCF that. So if I GCF 2x plus 12, I can divide a 2 out to the front. And then I look for what's left over. So 2x divided by 2 is just an x. 12 divided by 2 is a plus 6. Okay, then from there, I'm looking for the holes in the graph. The holes are the ones that cross out. I see I have an x plus 6 twice. I'm looking for what would make that 0. Well, then x would have to be a -6. Now, your vertical asymptote is any x's left over on the bottom. So look at your expression. I have an x left over, but it's on the top. That does not count for a vertical asymptote. So I don't have any x's left over on the bottom, then I would say none. My simplified expression is going to be x minus 2 over 2. Okay? All right, go down to the next one. Number 3, I have x plus 3, x minus 1. That part is already done. I'm just going to put a little check by it. Okay, that part is broken down for us. But then on the bottom, I'm going to have to factor this guy out. So think about your list on the front. I can't t-chart it. There's not a GCF because that's an x squared and that's a 9. They don't have anything in common. But I can do square roots. So the square root of x squared is going to be x. And then the square root of 9 is going to be plus or minus 3. So from there, I'm looking for what can cross out. That's going to create a hole in the graph. If my x plus 3's can cross out, because I had one on top, one on bottom, then the hole in the graph is going to be at -3. My vertical asymptote are any x leftovers, but they have to be on the bottom. So I'm only going to count this one as a VA, as a vertical asymptote. X minus 3, solution would be a positive 3. Then from there, my simplified expression is x minus 1 over x minus 3. All right, go down to number 4. Number 4, notice in this case the bottom is already done for me. They pulled a GCF out, so now I don't have to do that. 3x, x minus 2 is on the bottom. Put a little check here because they'd already worked that out for me. So take a look at the top. I'm going to need to do what kind of factoring on that. Your choices are GCF, nothing in common. Difference of perfect squares, nope, or t-chart. Okay, well that is a t-chart. -10 at the top of my chart. Can do 1 times 10 or 2 times 5. Okay, I want a 3 in the middle. Well, then I need 5 minus 2. So I'm going to have x squared minus 2x plus 5x minus 10. From there, I'm looking for a GCF. X squared minus 2x, they both have an x. 5x minus 10, they both have a 5. From there, take your x out to the front. I have an x minus 2 left over. 5x minus 10, I can take out a 5. 5x divided by 5 is an x. Negative 10 divided by 5 is a minus 2. Then I look at this guy here. I look at this guy here. They're the same. That's what I want. Then I have an x plus 5 from the outside. That's my second factor. So I'm going to have x minus 2 and x plus 5. Then I look for my common factor. I see my minus 2 is a repeat, one on top and one on bottom, which means that the whole from my graph is going to be at x equals positive 2. Okay, and remember, where does that come from? I let the x minus 2 equal 0, and then I have to bring the 2 across. That's why you're changing the sign on those guys. Okay, then vertical asymptotes are x's left over on the bottom. So remember, x plus 5 doesn't count, but 3x does. If I set 3x equal to 0, how would I solve that? I'd divide by 3. And 0 divided by 3 is still 0. So x equals 0 is my vertical asymptote. Now remember that we also talked about, okay, that whenever you have an x on the outside, you know that x is going to equal 0. So whenever you have an x on the outside, 0 is going to be your solution that goes with that. Then my simplified expression, I have an x plus 5 left over on the top. I have a 3x left over on the bottom. All right, moving on. Number 5. Okay, take a look at the top. I noticed there that I have a GCF. So I'm going to take that GCF out. So I have 2x squared. I can divide both of those by 2. So my 2 is going to come out. And then I'm going to have 2x squared divided by 2 is x squared. 98 divided by 2 gives me a minus 49. Now, after taking the 2 out, that is not broken down. I'm going to still have to factor it one more time. What you should notice is that this guy in here is a perfect squares. The square root of x squared is going to be a regular x. And the square root of 49 is a plus 7 and a minus 7. So my top one, I had to factor twice. Okay, first I removed the GCF, then I did a perfect square. Okay, so it is possible that you would have 2 steps to factor. Possibly pulling out a GCF, then doing perfect squares, maybe GCF, do a t-chart, something like that. Okay, so now let's look at the bottom. This is going to be t-chart. I need numbers that multiply to negative 14. So I could pick 1 and 14 or 2 and 7. But then I need them to subtract to a 5 in the middle. So the only way for me to be able to get 5 is for me to subtract. If I do 2 minus 7, that's going to give me negative 5. I see in the middle I want a positive 5, so I'm going to put the negative on the 2. From there, I'm going to do x squared minus 2x plus 7x minus 14. Then look for my groups. Can pull an x out of here, a 7 out of here. So my x comes to the front. I have an x minus 2. My 7 comes to the front, and I have an x minus 2 again. Then from there, I notice I have an x minus 2 repeat. That's what I want. And an x plus 7 is my second factor. Now remember, that was my t-chart, which was on the bottom. So when I copy it over here, I'm going to need to make sure that I keep things in the right spot. So my double factor was on the top. My t-chart factor is going to go on the bottom. X minus 2, x plus 7. Then I'm looking for my common factor. I see I have a plus 7 twice. Cross those guys out, there will be a hole at -7 in the graph. Because remember, -7 plus 7 gives me 0 on the bottom. Vertical asymptote, or any x's left over on the bottom, I have an x minus 2 left over. If it's an x minus 2, the vertical asymptote is at +2. Then my simplified expression, I have a 2x minus 7 over an x minus 2. Okay, so 2x minus 7 was left over on the top there, then an x minus 2 was left over off the bottom. All right, we have one more left. Take a look at number 6 for me, please. Okay, so number 6, first thing I notice on the top, I have a 4x squared minus 20x. It looks like there's a GCF in that. Okay, think about what you could divide by. 20 and 4 can both divide by 4, but is there something else? Okay, notice that both of those also have an x. So I can pull a 4x out to the front. 4x squared divided by 4x is just an x left over. -20 divided by 4 leaves a 5. Notice that I had an x, but I divided it out, so it's gone. From there, I look at the bottom. Okay, I have x squared minus 6x. Hopefully you notice that is also a GCF. Both of those can divide by x only. There's not a number, but remember, x counts as a GCF too. So my x is going to go to the front. From my x squared, I have an x. My 6x, I have a minus 6. Then I come over here to look for my holes and my vertical asymptotes. Now, look at your parentheses. Neither of those match. Okay, however, my x's can still cancel out. Now notice, when I cancel the x's out, I cannot cancel out the 4 because they don't have a 4. However, when I canceled an x that is out in front. And so when you cancel an x out in front, remember that means that 0 is the solution for that, so 0 is where the hole will be in your graph. Vertical asymptote is going to be any x's left over on the bottom. I have an x left over on the bottom. It's an x minus 6, so x equals +6. Then from there, for my simplified expression, I'm going to have a 4, x minus 5, and then an x minus 6. Alrighty, do your best. You have your homework that you should be able to work on for the rest of class. These notes are about 18 minutes, so you should have almost 20 minutes to get some work done on that homework. The sub has the answer key for you to check your work if you need to, and I will see you guys tomorrow. Have a great day.